Okay, welcome back. Again, what I want to do is continue with Sittingill's Electrotechnical Technology Level 2 course. Well, Level 2. Okay. Outcome 1. Describe the application of the basic units used in electrotechnology. Okay. And here we are. To understand how power is generated, to recognize the waveform from an AC alternator. Okay. Now, review of applications. Let me just step back a little bit. And this is just telling us what we've learned so far. And if you look at sessions 1, 2, 3, 4, etc., you'll see that we've actually covered all these elements. Okay. I would strongly suggest that you write them out for yourselves as well, so that you understand the concept and do some additional research. Okay. Electricity supply. Electricity is a relatively new source of energy. Well, not now, okay, basically, but it was at the time in 1831. Michael Faraday discovered how to convert mechanical power into electrical energy. Okay, so it's not that long ago, really. 1831 to 1931 is only 100 years. First practical application was a lighthouse in 1856. It was not until the 1880s that power was produced commercially. At the turn of the 20th century, the full benefits to industry were realized. Okay, and here are some of the items that we were using to generate electricity at the time. Coal, oil, gas, nuclear, hydroelectricity. Now we have wind, solar power, and obviously nuclear, which was previously mentioned. Okay. Now here's producing power. Okay, how power is produced. Coal, oil, and nuclear energy all heat water up until it is a high pressure steam. The steam then drives turbines. So here you have your boiler, there's a certain degree of heat loss, your turbines, okay, turning mechanical power. This mechanical effort turns a generator, okay, and that's your electrical power output. Now it's worth bearing in mind that your generators will generate 25,000 volts, okay. This is then transformed up to a very high voltage, okay. And if you want to know what those high voltages are, just look at go on Google, type in transmission power lines, transmission voltages, and that should actually provide you with some more additional information. Hydroelectric power. Okay, now again here we have just a simple turbine, water turbine, being driven by water, which generates electricity. Okay. Now this output here can go to a lower level reservoir, and then it's pumped back up to the reservoir. Okay. And that's your output voltage. You can see here 25,000 volts generated, and then it's transformed up to 400,000 volts. Okay. and here we have what we call pumped storage generation. Okay, this I'm not going to be reading this out to you. You can read this for yourself, and you can see the diagrams, okay, clearly there for yourselves. Okay. 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 Good. And here's your gas turbine. Okay. You have gas air intake, high compression. Okay. Combustion chamber ignites and drive turbines, which drives your electrical power or generation your electrical power, I should say. Okay. And here's power generation. Now we have three phases: phase one, phase two, phase three. Three phases. Okay. And our phase colors are brown phase, black phase, and your gray phase. Okay. Just make sure we can get this in. Okay. For fully up. Okay. Okay. And that is your alternator, how it is wired up. Okay. You can see here your rotor coils. Okay. Rotor coils, field coils. Okay. Okay. So okay. So I was just decalibrating for a moment, just making sure that power generators have three coils. Okay. As you can see, you can read that for yourselves. Don't need me to read that to you now. Okay. Let's bring that into play and make sure we can get it all into frame. Okay. And here's your sinusoidal waveform. Okay. And again, let's go into here. Let's make sure we can get that in frame for you. Okay. I've got this here for you. Okay. Now you can read this for yourselves. You don't need me to be reading this out to you. So again, it's for your edification. And this is how a single coil is illustrated here. Just a single coil, one piece of wire, whether it could be 6 inches long, it could be 12 inches long, it could be 80 inches long. One loop of wire, one end goes in, what is attached to one end, one corner, one coil. These are your brushes. These are your output connections. Okay. These are your slip rings. Okay. Here, these two here are your slip rings. Okay. So you can see that one end connects to one slip ring. The other end connects to your other slip ring. Okay. Well, one end connects to one or the other slip rings. As that coil rotates, it produces electricity, and this produces your output in regards to your cable and to your supply. Okay. Okay, now here you have a sinusoidal waveform, and all this shows you is starting rotation as it goes up and as it cuts lines of force, okay, north to south, okay, north to south, okay. And you can plot this waveform events here along your status. So you're here at this point, that is this point here, okay. That's your maximum peak value. And let me just make sure that I've got you in place. Okay, I don't want to be losing you. Okay, it's good. Have I got you? Got you in frame. Okay, that's fine. Make sure we have it in frame. Make sure we can go over there. Okay, yeah. Okay. And again, this just showing you your peak-to-peak value, and you've seen this in some of my principles work already. Okay, so it should not be anything new to you at this stage. But again, try drawing these out. Write down the information, make notes for yourselves. Okay, T equals 1 over F, F equals 1 over T, time and frequency, okay? Okay, and that should be it. Thank you for your time. I hope that you find this useful, okay? Have a good day. Bye-bye.